Hey everyone, in this video we're going to talk about substitution techniques. Substitution techniques. So let's start with a simple example and then I'll explain the general strategy. So let's say that we have to solve the following equation: x to the fourth minus 13x squared plus 36 equals 0. So first, I'm going to show you how to solve this really quickly without using a substitution technique. Then I'll show you the longer way with the substitution technique. You can solve it any way you like, obviously, so whenever it says use the substitution technique in the problem, you can always use this method, which I'm about to show you. So this will always factor as follows: x squared, x squared. These are rigged usually if they come from math books. So whatever is here will go here, okay? Always. Okay, whatever is there will go there if it comes from like a typical math book. And you can check. X squared times x squared is actually x to the fourth, because when you multiply x squared times x squared, you actually add the exponents. So 2 plus 2 is 4. And now we just need two numbers that multiply to 36 and add to negative 13. So I think 4 and 9 will work. And they should both be negative because the middle term is negative. And you can check. Negative 4x squared and negative 9x squared give you negative 13x squared. These continue to factor even more. X squared minus 4 is actually x plus 2, x minus 2. It's the difference of squares. Likewise, x squared minus 9 is actually x plus 3, x minus 3. It's the difference of squares. And then you set each factor equal to 0. I'll skip the steps here. Here you get negative 2. Here you get 2. Here you get negative 3. And here you get 3. And those would be the answers. So in general, if you have something like this, usually it factors. For example, if you had, say you had x minus 13 square root of x plus 36 equals 0. The same thing would happen here. It would factor. And then this is going to go here. It's just a trick. Square root of x, and everything else is the same. And then you would go from there. Now, what if you wanted to actually use a substitution technique and do it the way that usually textbooks teach it? Well, I'll do it down here. So solve, do the same problem. X to the fourth minus 13x squared plus 36 equals 0. So the idea is that we know that it's going to factor, and so we call this piece here u. So we let u be equal to x squared. And then this will factor, well, this will become, rather. So if u is x squared, u squared is x squared squared. And so u squared is x to the fourth. So this piece here becomes u squared minus 13. That's our u plus 36. So it looks much easier. So a substitution technique is really something to make it easier to look at, right? Because if we let u be x squared, then u squared is x to the fourth. So that becomes that. That's our u, and that hangs out. And now this factors. Let's finish it. This is u minus 9, and then u minus 4. We know that from before, right? And then we get u minus 9 equals 0. U minus 4 equals 0. So u is 9, and u is 4. But we're not done. Oh, no. We have to go back to x, right? So we said that u was x squared. So this is x squared equals 9, and this is x squared equals 4. And then finally, when we take the square root at the end, we get plus or minus 3 and plus or minus 2. So obviously this method takes much longer than the method I showed you initially. And it's really the same thing, right? It's really the same thing. So I hope that made sense.